Okay, this video is a workthrough on 2 of the problems from the Chapter 6 exam, the last exam we took in class, in person. And it's the first and last question from the calculator portion. So this is question number 1. We're given a function e to the x plus x to the fifth, and we're told that g of x is the inverse function, and we're asked to find the derivative. If you recall from class, there's an equation we learned tied to this that I said, hey, you can go ahead and memorize this. But there are some other avenues to finding the solution that I think are a bit easier as memory triggers to hang on to if you're faced with something like this. So what we're asked to do is find the derivative's value for the inverse at 7. And just as a reminder, if you're on an inverse function, so if we have g, so g of x is the inverse of f of x. So if there's a point on g that's 7 comma something, then that means there's a point on f that is something comma 7. And that's what it means to be an inverse. You just flip-flop the x and the y values. And so what we're looking for then is a place on the function that matches with a y value of 7. So I have an equation for the function. I'm going to put a 7 in for y. And by hand, you wouldn't be expected to solve this, but with a calculator, you can. And what this will tell you then is that missing x value on the function, which again is the associated y value on the inverse. So I'm going to take this expression, 7 equals e to the x plus x to the fifth, and I'm going to figure out what the x value is that makes that happen. And to do that, I'm going to go over to a calculator simulator I've got, and I'm going to go to y equals, and I'm going to graph 7. That's the left-hand side of the equation. And then I'm going to graph, let's see, it's a little clunky to use this, but let's go e to the x. I'll just put an x in there. So we've got e to the x. And then we're going to add x plus x. And we're going to go plus x to the fifth. And there's my fifth. And then what I want to know is where these two things intersect. And you can see the version I've got shows you a bunch of information. You can see the graph, what that looks like. Sure enough, there's an intersection point. So I'm going to go over here to the graph. And I'll plot out my horizontal line, my y equals 7. I'll plot out the right-hand side of the function, which is the red line that should be coming. There it is. And I'm going to find the intersection between those two. So I'm going to go to second trace. So calculate an intersection point, which is option 5. And first curve, y equals 7, that's good. Second curve, red curve, that's good. A guess, as long as we're close, we know there's only one intersection. So we can or should just be able to hit enter. Then we've got 1.199 to 3 decimals, so 1.199. And I'm just going to carry this through 4252. So I'll go back here and I'll say, okay, so that intersection happens at an x value, 1.1994252. And that's the x value that sits right here. It's also the y value that sits over here. But the reason it's valuable in this problem as an x value on the function is what I'm going to do is I'm going to say, okay, let's actually take the derivative. So here we've got f. And again, I don't know what the g function is. I'm not going to be able to swap out those letters, but I can go ahead and come up with a derivative. So I'm going to say, okay, f prime equals, well, let's see, that'd be e to the x plus 1 plus 5x to the 4th power. And then what I'm going to do is evaluate this derivative at the associated x value. So I'm going to say, okay, I've got an expression for the derivative. Go ahead and evaluate it at this associated value. So I'll go back to my graph, or back to my graphing calculator, and I'll go into y equals. I'm going to clear these other two things out because at this point now I don't need them. And I'm going to do my e to the x. So let's see, I'll go second e to the x, and then I'm going to go plus 1 and plus 5x to the, what would it be, to the 4th power, we said. And that's going to give me a graph, and they show it on the blue line down here. and I can go over to the graph. And then we want to know what this graph is worth at 1.1994252. So again, this is a graph of the derivative of f. Assuming I have that correct. Yep, that looks good. And there's my graph. And then I'm just going to go trace, and I'm going to punch that value in. So 1.1994252 and hit enter. And then that gives me 14.666358. So that's the y value associated with it. So I'll go back here and I'll say, okay, so on this derivative, when I plugged in the 1.199, what I got was 14.666358. And the tricky part now is what the heck to do with this thing. What we talked about in class is the related point, the flip-flopped point. So that's up here. This notion that you've got a reflected point means what on the function is slope is listed as rise over run. That's this thing over 1. On the inverse, we got to flip that. So just like you swapped the x and y values, you swap the positions of the rise and the run to get your answer. So the answer for the derivative of g evaluated at 7, and again, that changes because we're flip-flopping points, is this thing flip-flopped. So 14.66358, 1 over that. And if you do 1 divided by that, we can get a decimal. So we'll go back into our calculator, go out to our home screen, and just do 1 divided by 14.666358 and hit enter. And then we'll go to 3 decimal places past the 0. So 0.0682 would be our answer. So 0.0682 would be to 3 decimal places. So again, there's a few different ways I could have gone about this. Just to walk it back through, what I did, took the derivative, found the x value that's tied to this y value of 7 on the function, or another way to think about that is the y value tied to the x value on the inverse. Either way, the matching value. Then I took the derivative of f. So here's the process of taking the derivative of f. Evaluate that derivative of f at the matching value, the 1.199. Understand that when I have rise over run on the function, I'm going to have to flip that because I'm interchanging x and y values. So it's going to be now not rise over run, but run over rise on the inverse function. And then that's being evaluated at the matching point, which is 7. So it's a lot of kind of abstract concept steps as well as a few different calculator steps, but hopefully that helps to work it through. That's problem number 1. The other problem that we'll talk through is question 6, which is the last one. Question 6 actually is not calculator necessary. You can use a calculator on it, but this is a good example of maybe what would show up on the AP exam this year, where it'll be calculator able, but you don't really need it. So to find an equation for the tangent line to the curve, I want y minus y1 equals m times x minus x1. That's what my solution needs to look like. I've got the x value. That is 0. And what I need now are the y1 and the slope. And to get the y value, where x is 0, I'm just plugging that 0 into this thing. So it'll be e to the 0, because if you put a 0 right here and times it by y, you're still going to get 0. And then you're going to get 0 here for x, and then plus 2y. So e to the 0 is 1. And then divide by 2, and y is a half. So right off the bat, without doing any calculus, just algebra, I suppose maybe pre-calc you could call it, we've got our y1, we've got our x1. And all now we're after is the derivative, the slope, and evaluate that at the point 0, 1 half. So now I'm going to take the derivative on this thing. So let's see, I'll switch colors here to do a derivative. Let's go to red. If I take the derivative on the e to the x squared y, and derivative of e is always the e times, I have to use the product rule to do the derivative of the inside, which is the power. So it's going to be 2xy plus x squared y prime equals, and then if I do the derivative of the right-hand side, I'm going to get 1 plus 2y prime. So that's derivative of x is 1, derivative of 2y is 2y prime. And this red thing is my derivative expression. You don't need to do anything more with it than that. You don't need to isolate out anything yet, because what we're going to do is plug in this point, so 0 and half. So I'm going to say e to the 0 times a half. Well, that's e to the 0. 2 times 0 times a half. Well, that's 0. Plus 0 times y prime, also 0, equals 1 plus 2y prime. Well, 0 plus 0 is 0. E to 0 is 1. So 1 times 0 equals 1 plus 2y prime. 0 equals 1 plus 2y prime. Subtract a 1 and divide by the 2. And let's see, I'll scroll up just a little here. You'd have a negative half equals y prime. Again, not really calculator active question. Don't need to do anything anything more with it than what we've done in terms of computation. So that's going to go in for slope. And let's see, that would be y minus a half equals negative 1/2 times x minus 0. And you could leave it like this. You don't need to clean it up. Some students chose to, some didn't. If you wanted to write it as y equals mx plus b, you could. And it's neither better nor worse in either of these two ways. Just two different ways to express your solution. And that's it. That's the last question on the Chapter 6 exam.